Hello everyone, welcome to this fourth video on coding theory. This will give you one more type of problem of the same content which we covered in the third video, namely how to encode words. We will move on with the problem. We will have to find the code words generated by the parity check matrix H, and we have been given with the encoding function E, which moves from your B3 to B6. That is, a 3-bit word is now being converted to 6-bit word. We need to have three things in mind when we have the problems of this kind. The generator matrix G, which is going to be of the format IM augmented with A. The E of W, the coding function, which is giving the encoded word as W times of G. And the parity check matrix H, which is of the format A transpose augmented with IN minus M. Now we will fix the basic quantities over here. So what we know is E is going to be a function from B power M to B to the power of N. Now M is being identified as 3 and your N has been identified as 6. So the bigger word, that encoded word, is going to be N. So we have the extra parity bit to be added to be of length 6 minus 3, so it is going to be 3. Now let me fix the parity check matrix. We know that the parity check matrix is one which helps us to identify the error and correct the error in the decoded words. But the quantity is that I must have more number of columns than the number of rows. But this is happening the other way around. So before starting, we give you the caution that H always has more number of columns than that of rows. So if we have a format of this kind, then the first thing we need to do is we will have to take H transpose and then work with that matrix rather than this matrix. So keep in mind, my dear friend, whenever you have number of rows to be moved than that of the column, flip your matrix using your transpose so that you will have 1, 1, 0, 1, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1 to be your H transpose, and this now becomes my base for this encoding to happen for. So now I have this H to be of the format A transpose augmented with I n minus m, which is going to be 3. What is my I3? I3 is nothing but identity matrix of unit 3, which gives 1 0 0 0 1 0 0 0 1. And where it is present? It is present to the right side of your H. Come on, we will identify it. The I3 over here, 1 0 0 0 1 0 0 0 1, is present over here. So let me draw the imaginary or the augmented line over here, so that this part over here represents the quantity which is going to be my I n minus m, which is I3, and therefore what happens to the remaining part which is present over here? This is nothing but my A transpose. So this I identify it as A transpose and the second part as my I3. Now from my A transpose, I need to get my A to form the generating function G. So let me copy paste this to get my G. From my H, I can get my G, which will be of the format of G is going to be equal to your IM augmented with A. You have IM augmented with A. And what is my M? M is going to be 3. So we have I3 augmented with A. But what is our A? Where do we get it from? Yeah, we get it from this part of H, which is the parity check matrix, which involves A transpose. Now, my A transpose is given as 1, 1, 0, 1, 0, 1, 0, 1, 1. And how to get your A? it is going to be got by interchanging your rows to columns and columns to row. So this part which is over here will now be inverted to this way. Hence, I have this as 1, 1, 0. Next column 1, 0, 1. The third column 0, 1, 1. So your columns have now become rows. But the magic is, since the matrix A transpose is going to be symmetric, that is above and below the diagonal, the elements are the same, you have A to be the same as your A transpose. Now this A, let me augment with I3. I3 is the same identical quantity over here. So I have this as I3 coming first. So 1, 0, 0, 0, 1, 0, 0, 0, 1, which comes first, and then to which I augment my A, which is 1, 1, 0, 1, 0, 1, 0, 1, 1. So now I have my G to be generated. Using this G, I am going to encode my words. And what are going to be the words that are going to be encoded for? The encoded words are going to be bits of strings of length going to be of length 3, B3. So next I need to know what are going to be the 3-bit words. So we begin with, I know 0 and 1 are the two elements of my binary. So I have 2 to the power of 3, which is going to be 8 words that can be generated using the combination of zeros and ones, which are 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1. 1, 2, 3, 4, 5, 6, 7, 8. So now these are my inputs, W, the words which have to be encoded for. So these W now get into G and now get converted as E of W. So we know that E of W is given by W times G. We will now start with the first thing. We need to keep in mind the input is going to be a 3-bit word 1, 2, 3, and output is going to be a 6-bit word. So the first 3 are going to be the original data and the last 3 are going to be the parity bits which are going to be attached to. So the final string will be of length 6. So this is my original. So whatever you give as input, the same will be occurring in the first 3 positions, and the last 3 positions alone will get changed for. Okay, so we will begin the encoding now. Word 1 which we are going to encode is going to be 0, 0, 0, which is now going to be multiplied with our G, which is 1, 0, 0, 0, 1, 0, 0, 0, 1, 1, 1, 0, 1, 0, 1 and 0, 1, 1. Now we know that the final answer which we will be getting is going to be 6 bits long. And we know the rule of multiplication, a row versus a column. We need to keep in mind the basic thing that I know 0 plus 0 is going to be 0, 0 plus 1 is going to be 1, 1 plus 0 is going to be 1, and 1 plus 1 will be 0. Keeping this quantity in mind, I move across columns to get my 6 elements filled. Okay, 0 into 1, 0 into 1, plus 0 into 0, plus 0 into 0. Now this belongs my first element. So 0 into 0 is going to be 0, 0 into 1 is going to be 0, 0 into 0 is going to be 0. Next element, I move to the column number 3. 0 zeros are 0, 0 zeros are 0, 0 ones are 0. Next column 4, 0 ones are 0, 0 ones are 0, 0 zeros are 0. Next column 5, 0 ones are 0 plus 0, 0 ones are 0. And the last column, 0 into 0 is 0, 0 into 1 is 0, and 0 into 1 is going to be 0. Now I can make this as 0 plus 0 plus 0. 0 plus 0 is 0. Again a 0 plus 0 is 0. 0 plus 0 plus 0 gives me 0. Third 0, fourth, fifth, sixth. So I have the first 3 bits to represent my original data and the last 3 bits to represent the decoded word parity bit which has been attached. So these are the extra bits which have been generated. Note, for always a 0 word, the entire output of the strings will be zeros. Now we will start encoding the second word, which is going to be 0, 0, 1 with my matrix 1, 0, 0, 0, 1, 0, 0, 0, 1 augmented with 1, 1, 0, 1, 0, 1, 0, 1, 1. We need to move a row across a column. So we will make this as the first element 0 into 1, 0 plus 0 into 0, 0 plus 1 into 0, 0. Next 0 into 0, 0, 0 into 1, 0, 1 into 0, 0. Next element 0 into 0, 0, 0 into 0, 0. Now I have 1 into 1 which makes it as 1. The next element 0 into 1, 0, 0 into 1, 0, 0 into 1, 0. Next element 0 into 1, 0, 0 into 0, 0 and 1 into 1 is going to be 1. 0 into 0, 0, 0 into 1, 0, 1 into 1 is going to be 1. So now what do we have? Let me do the addition. 3 zeros together makes it as 0. 3 zeros together makes it as 0. 0 plus 0 is 0 and 0 plus 1. 0 plus 1 is going to be 1. So I have this entry as 1. 3 zeros together makes it as 0. 0 plus 0 is 0 and 0 plus 1 is going to be 1. 0 plus 0 is 0 and 0 plus 1 is going to be 1. Again we notice that the first 3 bits 0, 0, 1 is reappearing over here 0, 0, 1 and the last 3 bits are nothing but my parity bits which have been attached for. Let me go for the third word 0, 1, 0. So I have this quantity as 0, 1, 0 and now I need to multiply this with my matrix called as G. So here we go. Multiply a row with that of a column. So what gets generated over here is 0 into 1, 0 plus 0, 1 into 0, 0 plus 0 into 0, 0. Next element 0 into 0, 0 plus 1 into 1 is 1 and 0 into 0 is 0. 0 into 0, 0 plus 1 into 0, 0, 1, 0 into 1, 0. Next 0 into 1, 0, 1 into 1 is 1, 0 into 0 is going to be 0. The next one 0 into 1 is going to be 0, 1 into 0 is 0 and 0 into 1 is 0. The last element 0 into 0 is going to be 0, 1 into 1 is going to be 1 and 0 into 1 is going to be 0. So let me decode this as all the 3 zeros is going to be 0, 0 plus 0 is 0 and 0 plus 1 is going to be 1. All 3 zeros, 1, 1, a 0 and a 1. Notice 0, 1, 0 over here has been replicated as the same 0, 1, 0 and the remaining 3 are going to be my parity bits. Okay, third word done. I am going on with the fourth word. What is the fourth word? 1, 0, 0. So 1, 0, 0 with that of 1, 0, 0, 0, 1, 0, 0, 0, 1. 1, 1, 0, 1, 0, 1, 1, 0, 1, 1. Okay, we will begin. 1 into 1 is 1 plus 0 plus 0. Next 0 plus 0 into 1 is going to be 0 plus 0 into 0 is going to be 0. Next column number 3 is 0 into 1 is going to be 0. 0 into 0 is 0 and 0 into 1 is going to be 0. Column number 4, 1 into 1 is 1. 0 into 1 is going to be 0. 0 into 0 is going to be 0. Next one, 1 into 1 is going to be 1, 0 into 0 is 0, and 0 into 1 is going to be 0. Last, 1 into 0 is 0, 0 into 1 is 0, 0 into 1 is 0. So we decode this as 1 plus 0 plus 0 is 1, 0 plus 0 plus 0 is 0, 0 plus 0 plus 0 is 0. Again over here only 1, 1, 1, 1, and this is going to be 0 everywhere. Again we notice what happens over here. The first 3 bits 1, 0, 0 is replicated over here, and the last 3 bits are going to be the newly added words. Then last word, sorry, not the last one, the next word to be included is going to be 0, 1, 1. 0, 1, 1 with 1, 0, 0, 0, 1, 0, 0, 0, 1 added with 1, 1, 0, 1, 1, 0, 1, 1. Let me make this one. Now 0 into 1 will be 0, 1 into 0 is 0, 1 into 0 is 0, 0 into 0, 0, 1 into 1 is 1, plus 1 into 0 is 0, 0 into 0, 0 into 1, 1 into 1. Okay, 0 into 0, 1 into 0 is 0, 1 into 1 is 1. The next column, what we have, the fourth one, 0 into 1, 0, 1 into 1 is 1, and 1 into 0 is 0. The fifth one, 0 into 1 is 0, 1 into 0 is going to be 0, 1 into 1 is 1. And the last one, 0 into 0 is 0, 1 into 1 is 1, and 1 into 1 is 1. This can be written as 0, 1, 1, 1, 1. Now 1 plus 1, what is 1 plus 1? That makes it as 0. So again we see 0, 1, 1 over here is replicated over here, and the last 3 are going to be the added words. Moving on, what will be the next one? We have is going to be 0, 1, 0, 1. We will make this as 1, 0, 1. So 1, 0 shifts over here. And what is going to be our G? So go on with your multiplication. So we have this to be equal to 1 into 1 is 1 plus 0 plus 0. 1 into 0 is 0 plus 0 plus 0. 1 into 0 is going to be 0 plus 0 into 0 is 0. 1 into 1 is 1. The next one, 1 into 1 is 1 plus 1 into 0 is 0, and 1 into 0 is 0. 1 into 1 is 1 plus 0 into 0 plus 1 into 1 is 1. 1 into 0 is 0 plus 1 into 0 is 0 plus 1 into 1 is 1. So we have this as 1, 0, 1, 1. 1 plus 1 is going to be 0, and this is going to be 1. We notice 1, 0, 1 over here is replicated the same way as 1, 0, 1, and last 3 are parity bits. And now the last of the combination with the two ones, 0, 1, 1, 1, 0, 1, 1, 1, 0. We move with this 0, 1, 0, 1, 0, 1, 0, 0, 1, 0, 1, 1. So we have this as 1 into 1 is 1 plus 1 into 0 is 0. 0 into 0 is going to be 0. 1 into 0 is 0. 1 into 1 is 1. 1 into 0 is 0. 0 into 1 is 0 plus 1 into 1 is 1. Sorry, 0 into 0 is going to be 0, and 0 into 1 is going to be 0. 1 into 1 is 1, 1 into 1 is 1, 1 into 0 into 0 is going to be 0. So 1 plus 1 plus 0. Next one, 1 into 1 is 1, 1 into 0 is 0, and 0 into 1 is going to be 0. The last one, 1 into 0 is 0, 1 into 1 is 1, 1 into 0 is 0. So we have this to be encoded as 1, 1, 0, 1 plus 1 is again a 0, a 1, a 1. So again we notice first 3 bits are the same, and the last 3 bits are going to be the generated one. The last word 1, 1, 1 to be encoded with the matrix 0 1 0 1 0 1 0 0 1 0 1 1. We will go 1 into 1 1 plus 0 plus 0, 0 into 1 is 0 plus 1 plus 0, 0 0 1 1 1 0. The next word 1 0 1, and the last word 0 1 1. So this makes this as 1 1 1 1 plus 1 is 0, 1 plus 1 is 0, 1 plus 1 is 0. So we see that 1 1 1 which appeared here again appears over here as the same, and the last 3 bits are going to be the parity bits attached. So this problem gave you the insight of how to encode a 3-bit word, and the caution which was given to you is if H contains more number of rows than column, first flip it, that is transpose it before you start working, and then encode the words. If this is going to be missed, I don't think the problem will work. So be cautious about whether your H is going to be in the proper order before performing the action of encoding. Happy learning, keep learning. Thank you.